Literal equations. So a literal equation is just an equation that has several variables and it's typically some sort of formula used for calculating something. Many formulas, such as um, the ones from geometry for calculating area, formulas from physics, engineering, are examples of literal equations. It is sometimes the case that we want to solve for one of the letters in the equation in order to make certain calculations easier or to express a certain variable as a function of the other variables. The good news is that solving for one of the variables in a literal equation follows the exact same basic rules for solving equations that we have already reviewed. We just laser focus on one variable and then work on getting all the other variables out of the way until we isolate the desired variable. So, for example, we're going to do two examples because it's really all the same. Again, you just want to laser focus on one variable and just move all the other variables out of the way by applying the usual operations. So, for example, this one says ax plus by plus, ax plus by equals cz. Let's say we want to solve this equation for x. So they tell us for which variable we want to solve. So that means we want to isolate the x, and that means therefore that everything else needs to go, needs to move away to the other side. So that means in this particular example that by needs to move. This needs to move to the other side. So that means this is going to become ax equals cz minus by, right? So you have plus by, so when you move it to the other side, it is going to become minus by. And then to get the x all by itself, we have to divide by a, because that a, really, we follow the same logic, so that a behaves like a number. So if we had like something like 5x equals 25, to get the x all by itself, we divide by 5, both sides. So it's really the same thing. If the equation had been like ax equals 25, well, we'll still do the same thing. In this case, we would divide both sides by a to get x. So is really follows the same rule here, same logic. So in order to get this x all by itself, we have to divide by a. So this is going to give us the answer. So x is going to be cz minus by, all that over a. Okay, let's do another example. This one. T equals mv squared over u plus 5. So in this case, we would like to solve for v squared, meaning I want the v squared part all by itself. I want the v squared part all by itself. Okay, now notice that in this one, there's like a little bit of a fraction there. There's a denominator. And remember the trick I told you to deal with this kind of thing, to deal with equations that have fractions or denominators. What you want to do is get rid of them. And the way you get rid of them is by finding the least common denominator of all the fractions that you see and multiply by that throughout. In this case, there's only one single fraction, so the LCD is just that denominator. So in this case, the LCD is just u. In this case, the LCD is just going to be u. So that means we're going to multiply the entire equation, so everything in that equation, by u. So that means the left gets multiplied by u. It's going to be t times u. And then the right as well, so mv squared over u. This term gets multiplied by u, and the 5 gets multiplied by u. Every term in that equation gets multiplied by u. And the idea is that after you do this, and you cancel, you shouldn't have any denominators left. And indeed, those go away, so what you end up is with tu equals mv squared plus 5u. Okay, now remember our goal is to have this v squared all by itself. So that means this 5u needs to move to the other side. That needs to go because I want to have the v squared all by itself on one side. So let's subtract then the 5u and move it to the other side. This is going to be tu minus 5u equals mv squared. And then lastly, to get v squared all by itself, I need to get rid of the m. And to get rid of the m, you just divide by m. So this is going to be divided by m, divided by m. So this is going to be then v squared equals tu minus 5u over m. And that is the answer. Okay, so you could keep the answer like that, or note that the u is repeated on the top, so you could actually factor it out, and say and rewrite the answer like this. U is repeated, so you can factor it out. This is not necessarily, but you could do that. You could do that, and that's another way of writing the answer. So factoring out the u that is common, you get u, then t minus 5 over m. So that would be another way of writing the answer. Sometimes we do have to factor in order to isolate variables. So keep that in mind. Sometimes it might be necessary to factor a variable out when you're trying to isolate things. In this case, we didn't need to do that. So that's it. Just try to follow the same logical rules that you follow for isolating variables. Try to get all the other variables out of the way, laser focus in on one, and that's it. That's how you solve literal equations.